15.3, part-way quadrilateral. Here's quadrilateral ABCD. All right, and it looks to be a parallelogram. I can tell that these two sides are parallel because they're both horizontal, and these look like they have the same slope. So I would assume this is a parallelogram. Okay, so number one, find the points that partition segment AB in a 1:4 ratio. Label it B prime. Okay, so the first thing I'm going to do is I'm going to label all my coordinates. So this is 2, 3. This is 6, 3. This is 8, 9. And this is 4, 9. All right, so for AB, I'm going to use my formula. So I know that for my X new, I want the first thing, well, let me just write my formulas here so as you're looking along, you can sort of reference them. X new equals X original plus change in X times the ratio. And Y is just the same thing. Y new equals Y original plus change in Y times the ratio. Okay, so I'm not going to rewrite that formula again. I'm just going to have it right there to reference. Okay, so for my X coordinate, I'm going to start, right, it says AB, so that's the direction I'm going, starting at A, so that's starting at 2, plus my change in X, so if I'm going from 2 to 6, that's a change in 4, times my ratio. A 1:4 ratio really means 1/5, because the first number is 1, and then if it's 1:4, in total I have 4 things, right? If for every 1 skittle I have, you have 4, together we have 5 skittles, so one of those 5 belong to me. And that ratio, right, is 1:5. So not going to be a pretty fraction, but you know, what can you do? Okay, that's equal to 2. I do normally like fractions, but let's just write this as 0.8. And then that's equal to 2.8. All right, Y is going to be starting at 3, plus change in Y is 0. So actually, I'm not going to move it all here. It's going to be 3 plus 0. And that's equal to 3. So my new point here, B prime, is going to be 2.8, 3. All right, so 2.8 should be right about here. And 3 stays the same. That's B prime. This will be very not too far along the way. All right, but we know it's 4 across here, so that's about 1/5 of the way from A to B. All right, find the point that partitions AD in a 1:4 ratio. So we're going to start out the same way because we're still starting from A. So 2, 3. Okay, my change in X, if I'm going from 2 to 4, 2, 3 to, let me write the coordinates right here. That is probably helpful. If I'm going from 2 to 4, it's plus 2. 3 to 9 is plus 6. So my change in X is 2. My ratio is still 1/5. 2 plus 0.4 is equal to 2.4. 3 plus my change in Y is 6. Still ratio of 1/5. 3 plus 1.2 equals 4.2. So that's my coordinate. D prime is 2.4, 4.2. 2.4, it's right about there. And then 4.2, we can see is actually, it's still on the line. We haven't even left this side, which makes sense. It's got to be. It's got to be somewhere. If it's not on the line, then we did something wrong, right? Because if we're finding 1/5 of the way from A to D, that's got to be on this path. It can't be anywhere else besides on this line. So right there looks about right. And that's D prime. 3. Now we're doing AC. So I'll do the same thing. AC, we're going from 2, 3 to 8, 9. We can see here, this is a little bit different because this is not a side of that shape, but it is the most direct path from A to C. Okay, and you'll see why they chose that in a minute. So if I want to find my X and Y, again, we're starting at 2, 3. My change in X is plus 6. my change in y is plus 6 as well. So they're going to look very similar, these two formulas, because the change in x and change in y are identical. So we'll have 2 plus 1.2, 3 plus 1.2, and that'll be 3.2, comma 4.2. All right. So 3.2 is right about here, 4.2 is right there, and that's C prime. All right, that looks, if I were to connect these now, it looks very similar, haha, no pun intended, to this original shape. Okay, so question 4 they ask, is A, really they, oh no, A stays the same. Is A, B prime, C prime, D prime a dilation of the original ABCD? Justify your answer. Well, what makes something a dilation? Well, when we actually construct a dilation, we make lines of projection, right, to every vertex from the center. So here we can see that A is the center here. So if we draw our lines of projection, right, we're going from A to D, A to C, and A to B. Now, you may not realize it, but when you're using a compass to do a dilation, especially if it's if the scale factor is less than 1, you're let's say you're doing one of 1/2, right? If we were doing something of 1/2, we'd be cutting this side into 2 equal parts, right? And that midpoint would be our dilation of 1/2. Now we're kind of splitting it into 5 equal parts. So I can match my compass up with this length here, and then I can jump ahead. That looked like 4. Did I make a mistake somewhere? Let's see this one. It's 1, 2, 3, 4, 5. So that one looks all right. Maybe I made a mistake here. Let's double check. Oh no, maybe my compass was just off a little bit. Or maybe my, wherever I thought the point was off. Oh, okay, I see it's a little bit off. If I'm talking about 4.2, this probably would be a little bit lower, probably a little bit closer. So that's human error, I would assume, why that one's off. But the other one should be pretty good. That looks like it's about 1/4 of the way, 1/5 of the way in here. Let's see, this also I think could chalk up the human error because it's not easily on the grid. 2, 3, 4. Did I make a mistake? I don't think I did. Let's just check the coordinates for some of these. This should have been 3.2 and 4.2. So I guess, yeah, this really should have been a little bit lower, like probably like right about here. And this probably should have been a little bit lower too. So that might be why it doesn't work out so perfectly when I try and trace it with a compass. Maybe this new length will be better. All right, that's 1, 2, 3, 4, 5. It's a little bit off, but I'll chalk that up to human error. Let's see about this one. 1, 2, 3, 4, 5. Yeah, there we go. So, that's a human error issue why it didn't work out perfectly. But you can see that each one of these segments is 1/5 of the way to there. So we can say that, yes, we dilated A, B, C, D by a scale factor of 1/5 centered at the origin. I'm sorry, not the origin, centered at A. Because A stays the same, so that's where the center has to be if that point doesn't change. All right, how were we able to justify it? By drawing lines of projection. You can tell the scale factor is 1/5, which it should be, because we cut every line segment into fifths and took the first fifth of that. So that makes sense. All right, that is all for 15.3.